Okay, with this one, I'd just like you to copy it down and we'll do it together at the next class. Give it a go and see if you can work it out. So this is, just to give you a little hint, this is the transition matrix. Obviously, you do the transition matrix would have been times by your little original point matrix, and that gives you the new image. Yeah. So essentially, this is the one we want to find. We want a situation where it's telling me what that one equals by itself. So it's doing the same process, and then once you get to the end of that, so you'd have, technically, you've got x, y equals, and you'll sub them back into this equation. Give it a go, and I'll check with you tomorrow that you've done it correctly. All right, so we're going to do this last example. So a transformation matrix is defined by here. So they've given us a transformation matrix, and often we give the letter T to indicate the transition matrix, just when we're trying to sort of summarize what's going on. Now, it says find the equation of the image. So they want to know the new transform equation and of the graph. So this one. So if you look, this is the original formula, the original function or whatever you want to say, and you want to get the new one. So if you remember, you know when we normally say x dash something, and then we say what happens to x in the transformation, and then the y dash something happens to the y, and then don't you remember when we then rearrange it to get x and y equals something? Yeah, and they'll have the dash or something, the dash involved in the formula. Do you remember that? Yeah. So what we're doing with matrices, we are actually, we find that final bit by solving the matrix over here. So I'll just go and explain. So we know this is the transition matrix. So here's the transition matrix. We times it by, this would have been the original point. So for us, so this is here. So it would be x and y. And then it equals the new image point. This is the image point. So we gave the image point would have looked like x dash, y dash. Now, because when we solve it all, we actually want what x equals, y equals. So we can solve it using these this matrices. So because we want to bring we want to get this one by itself, which is this, we're going to bring the t on the other side. So, which is, we could do the transition to the power of -1. Yeah, because remember that's like dividing in matrices. Because we can't divide, so we do times by the inverse. Times, that should be x dash in there. X dash, that one. Okay, so if you have a look, so let's set that up and try and solve that here. So you need to find, first we need to get, so I'm going to say we're going to find the inverse matrix of T, matrix T. So remember the inverse, you first need, so if T is equal to 1, 2, 0, 0, first we need to get the determinant of T. And what's that? Remember, the determinant is, we could go 1 times 2, isn't it? Yeah, minus, so 1 times 2 minus, isn't it 0 times 0? Yes? 0 times 0, so the determinant equals 2. And then you follow the inverse, so I'm doing inverse T is actually equal to 1 over the determinant, which we've just found is 2. And if you remember we swap these numbers. So 2 will come up here, 1 will go up there, and then we make these ones negative. So if I make 0 negative, is that really going to affect it? No. So that becomes like that. Now, remember when you got that set up, that's like saying times. So if we just tidy that up, so 2 times a half would be 1. Anything times 0 is 0. And a half times 1 is a half. So you now have manually found out what that t is. And that is, see this? And we need that for this part of our solving. Okay, so really, let's go and work this out now over here. We're saying matrix X is going to equal the inverse T times the image 1. So you just told me what inverse T is, so we've calculated all of that up. 1, 0, 0, a half. And we're going to times it by the image 1, which is like saying image X, image Y. Okay, and this one is essentially like X and Y, the original. Okay, so you now got to go and practice your run and dive. So you would go run and dive. So the first one, it'd be 1 times image X, so it'd be X dash plus, what's anything times 0? 0, so it's not really changing there. And then we'll do the next one, run and dive. So it'll be 0 times image X times a half times image Y. So won't that one be, it's like a half image Y, yeah? Really, you could tidy that up. We should really write it as Y dash over 2, because that's like times in by half. So what you have now found out is really, so X and Y. So you've found out that X actually equals image X. So when you go to transform this function, the X hasn't had any changes made to it, has it? And the Y is actually Y dash over 2. So you're going to pop them into here. So every time I see Y, so I'll put Y dash over 2, and every time I see X, obviously is X dash squared, doesn't matter. So if you have a look, do we normally leave the Y like that with the 2? No, we tidy it up, don't we? Yeah. So what's actually happening is that 2 will come over, but it'll times everything over there. So just be careful. Okay. So we've actually found the equation. You could leave it in any way, like we would actually give you that correctly. That's correct. That could be correct. Or you could even, if you wanted to, expand it out. And that would also be correct. Yeah? So really, if you have a look, just to practice, what transformation has happened? So we actually, if you look over here, if we would have had Y, 2Y equals dash Y. So what did we do in the new thing? We have dilated by 2 from the x-axis. When the y is affected, remember? Yeah, a little bit confusing, I know, but anyway. So that's